So here is a temperature sensor. It's a linear system. On the right, what you see is a inverting amplifier. And the reason it's an inverting amplifier is because if you look at the negative terminal, it's connected to the source right here. Correct? Okay, here are a few parameters given here. Vs at 0 degrees centigrade is 0 millivolt. At 100 degrees centigrade, Vs, which is basically the input signal to the circuit, is negative 100 millivolt. Remember, you got Rs and R1, those are connected in series, and this is R2, this is your feedback resistor. The reason we call it feedback resistor is because the output of the op-amp, output of the operational amplifier, by the way, this is going to act as an ideal amplifier, which means infinite input resistance, zero output resistance, and infinite gain, right? So the output is connected to a feedback resistor and then fed into the input of the op-amp, right? Hence R2 is basically the RF here. At 100 degrees centigrade, the maximum value for output voltage, due to the tolerance in R2, Now, if you look at over here, R2, which is a feedback resistor, it's rated at 1 mega ohm plus minus 1%. So if you look at it, if I try to find out the range for 1 mega ohm resistor with plus minus 1% tolerance, I get the range which is going to be 0.99 mega ohm to 1.01 mega ohm. Now, you should know that your output voltage is just simply gain times the input voltage here, right? And notice here, the input voltage is labeled as Vs, so I can rewrite this equation as A dot Vs. It's pretty much the same thing, correct? The higher the gain, the higher the output voltage, which means if you look at the gain equation for an inverting amplifier, there's a separate video that I've done on this, like how do we get this equation? I'll leave the link in the description. Gain equals to negative RF over RS. This is the equation for the gain for a inverting amplifier. If I plug in the value, this RF value, it's gonna be the highest value over here in this range, okay, not this one. And the reason for that is because, like I said, higher the gain, higher the output voltage, because we are looking at the maximum value. This is important here to understand. And because RF is in the numerator in this equation, higher this value, higher the gain. So negative RF, again, just to remind you, R2 here is basically a feedback resistor. So this comes down to 1.01 mega ohm, correct? RS, this is the source resistance, okay? This is the resistance that is fed into this part of the network. And because the two are arranged in series, so we can just simply add them, 2 kilo ohms plus 8 kilo ohms. And that would give us 10 kilo ohm, right? Ohms and ohms will cancel out. And if I do the math here now, I basically will get negative 101. Now, knowing V out equals to A dot Vs, now we're going to plug in the value of A that we just calculated here in this equation to find out V out. So V out here, V out equals to A dot Vs, and remember we are doing this at 100 degrees centigrade, correct? So A is going to be negative 101, correct? Vs is rated at negative 100 millivolt at 100 degrees centigrade. So we get negative 100 millivolt. So if minus and minus will cancel out, and if I do the math here, 101 times 100 millivolt, that equals 10.1 volts. And that is the maximum value for an output voltage due to the tolerance in R2. That is your answer.